Alright, and hopefully y'all can hear, by the way. Alright, and hopefully y'all can hear. Also, by the way, I had it open my computer, so I'm going to mute it because you're not going to get twice the sound. Awesome. Okay. Alright, so we have A. Yeah, I was about to type in that, Luke. Good advice there. Try refreshing your page if it's still not working. I don't know why I'm saying that, because you can't hear me if you haven't refreshed the page in this scenario. So. Cool. Good. Awesome. Let's finish up these Venn diagrams first. Then we'll get to exponents. We won't do anything new today. We're just going to go over stuff that we've worked on already, which I think it's important that we just make sure we're okay with this stuff before we move forward. That's the whole purpose of this class. Okay, so A union B complement. We look at what is inside A. Now A encompasses 2, 5, 7, and 8. And then we look at B complement. Okay, and B complement is now everything that is outside of B. Now B incorporates these 4 regions. So everything outside of B will be 1, 2, 4, and 7. And so because we have the union, we're going to combine those together. So between them, we get 1, we get 2, 4, 5, 7, and 8. So all of these sections, which is 1, 2, 4, 5, 7, 8. So what we're leaving out is 3 and 6, essentially. Okay. So we would shade in everything here except for 3 and 6. When we say union, we would want to make sure all 4 of these are part of this group, as well as all 4 of these. Right, everything but 3 and 6. I'm not sure what y'all are talking about with Luke, with B complement with no number. Do you have a problem on from the textbook where it has numbers on some of these? Oh, it's from the canvas. That is frustrating. Let's do one more of these. Pick a crazy one this time. Most of these look kind of crazy. Let's gosh. Let's go ahead and look at 15. It's A intersect B complement union C. Okay. Now the order of operations is important in Venn diagrams, so we can see the parentheses. That tells us we should do that one first, of course. So let's look at A and B complements. Now this actually utilizes the same thing that we found in number 11. A we know is 2, 5, 7, and 8. Okay, yeah, we can look at that next. In between. B complement is 1, 2, 4, and 7. This time, though, we're looking for the intersection, so where do these two things overlap? Right, 2 and 7. Both of them have a 2 in common and a 7 in common. Okay. Which you can't see because I wrote down on the page. Alright. And then we have C. Now, circle C has 4, 6, 7, and 8 inside. These 4 different areas. Okay. And so if we want to put those together, and we want to find a union, what would that give us? Two, 4, 6, 7, and 8. Yeah, we have a 2 and a 7 here, and we add the 4, 6, 7, and 8 here. The 7 occurs twice, but we only need to count it once, of course. So that would be regions 2, and then also 4, 6, 7, and 8. So that would be all of C, 4, 6, 7, and 8, plus region 2, which is inside A, but outside the other two. And so we would shade in region 2 and then all of C. That helped me understand a lot better. I know when I was learning it, So it's one way you can proceed. Nice little way to look at, and part of it's like looking at pictures versus looking at characters, like numbers or letters. It's just depending on how you learn. Some people are perfectly comfortable using the pictures and thinking about it that way, but other people may feel more comfortable, like I'm doing here, assigning some kind of number to represent that area, and we can just work with the numbers then from there. This is really just a matter of preference at this point. Okay. Now, when y'all are talking about the rule of counting, it depends what course you're in, what we call it. And if it is what I'm thinking about in statistics, for instance, we call it the addition rule. Is this what you mean? Something like that. Wait a minute. I don't think I wrote that down right. Sorry, that seems redundant. I always saw A union B as A plus B minus A intersect B, something like that. Yeah. Please, let me know what y'all mean by rule of counting, because in different classes we call it different things. It's not like De Morgan's law or anything like that, is it? We use this in statistics for probability, which you'll get to eventually. Oh, I see it. Yeah, I almost had it right that time, but we went ahead and put an N on the outside. That's what it was. So we want the number of elements in that set combination equal to the number of elements in that set combination plus the number of elements in that set. Yeah, okay. Okay. So the way I like to demonstrate this let's say set A is the even numbers from 1 to 10. And we'll let B equal the, let's say we have 3, 6, and 9. So this will be the multiples of 9 between 1 and 10. or multiples of 3, sorry, between 1 and 10. Okay. So when we say n of A, how many elements does set A have? N of A is equal to 5. We have 5 elements there. And then we look at n of B, and we can see you have 1, 2, 3 elements in B. So n of B is equal to 3. So when we take a set and we put n and then parentheses around that set, that we want to basically count how many different values or how many different elements or does that set consist of. So A consists of 5 values, B consists of 3 values. Now next, let's look at the set A intersect B. What are the elements that A and B have in common? Or how many elements do A and B have in common? Right. They both have a 6 in common. So the number of elements they have in common is 1. Yeah, I don't know if I phrased that the way I was asking it. Well, I wanted to ask it, so I apologize for that. But it looked like a couple of y'all figured it out at least. Several of y'all. So what about A union B? What values are in the set A union B? That's correct, Brenda. Mm-hmm. Yeah, so A union B, we have 2, 4, sorry, 2, 3, 4, 6, 8, 9, 10. We'll get to the Venn diagram. I want to do it separate from the Venn diagram first. Is that 7? Yeah. So the number of elements in A union B is 7. Okay. And so now we bring back in our rule of counting here. And it says the number of elements of A union B Sure, we can do that. A union B is 7 elements. A, n of A, we said was 5. N of B is 3. And n of A intersect B is 1. So we're saying 7 is equal to 5 plus 3 minus 1. Which is a true statement because that's 5 and 3 is 8, minus 1 makes 7. So the reason that this works, the reason that we have this rule of counting is that if we're finding the union of two sets, A has 5 elements, B has 3 elements, so we'd say, well, there must be 8 between them. But the issue is that just by adding the two elements of the two sets together, it doesn't take into account what they have in common. Because the 6 occurs in both of these sets, we don't want to count the 6 twice. So by adding 5 and 3, we've counted the 6 2 times. So, I just made this up, Mary, so I apologize. It's not out of the book. So, we have 5 elements here, 3 elements here. There's 8 altogether. However, 6 is duplicated in both sets. So, because whatever numbers are in common to A and B end up being counted twice, we take away the intersection of A and B, because if it's counted twice, we want to remove it once, so each 6 is only counted one time. And that's why we have the rule of counting, is that if there is some kind of overlap between the two sets, then we end up counting those values twice, and we want to take it away once, so that we've effectively only counted that 6 value one time. Excuse me. Let's look at that in Venn diagram form now, the rule of counting. So in a Venn diagram, here's our circles A and B. So if we take A union B, that means we're taking everything inside this circle, inside of circle A. We're adding everything that's inside circle B. Now what happens is everything that falls inside this middle region, this was counted as part of A, and it was also counted as part of B. So when we add these two together, we count this region twice. And so what the rule of counting says is that, okay, we took this, we added this, we counted this twice. This area, which again we've labeled as A intersect B, because we've already counted that twice, we want to take it away once. By subtracting it once, that effectively counts all 3 pieces here separately, and we have an accurate total of what is inside the union of both sets. So, let me see if I can find a problem. Okay. So this is example 6 on page 413. There's other examples in the homework, but this is a relatively short one that allows us to illustrate what's happening here. A group of 10 students meet to plan a school function. All of the students are majoring in accounting or economics or both. So we have 5 economics majors. We have 7 accounting majors. How many major in both subjects? Okay. Sorry, I keep going crazy with my boxes here. I don't know what's happening. So we have economics, we have accounting. So we know there's 5 in economics, and we know there's 7 in accounting, and we know there's 10 altogether. So we know that there's 10 students altogether here. But if we look at 5 economics majors and 7 accounting majors, that's more than 10, right? 5 and 7 is 12. So we look at that and we say, okay, how many over 10 do we go? By how far over 10 does that sum go? Okay. And this is where the formula comes into play. Economics, we'll just call that set E, and accounting, we'll call that set A. So number in E is 5. Number in A is 7. And then E union A is 10 students total. So when we say union, that means accounting or economics or both. So our formula says, I moved it up, I'm sorry. Our formula says that N of E union A is equal to N of E plus N of A minus N of E intersect A. So we know this number is 10. N of E is 5. N of A is 7. And this number is unknown. So looking at this equation, how many people are in this last group? $12? 2? So 5 and 7 is 12. Take away what number to equal 10? Well, 12 minus 2 would equal 10. And that's one of the things that is important to make sure we have kind of straight in our minds before we move forward with this stuff is recognizing, okay, this symbol means this symbol means that. So yeah, there's 2 of these students that are majoring in both economics and accounting. So if we were to create a Venn diagram now, or fill in the Venn diagram, we now have 2 people in the center where it overlaps. How many are on the economics side over here in this part of the graph or diagram? We know we have 5 economics majors total, so there's 3 more that would just be economics but not also accounting. How many are over here? We have 7 accounting majors total. 5. Yeah. So that's 3 plus 2 plus 5. That's all 10 of our students. Okay. 3 are just economics. 5 are just accounting, and then 2 more are both economics and accounting majors. They're double majors. So that means 5 are majoring in accounting, 5 are majoring in economics. These 7 are inside the accounting circle, so they're majoring in accounting, and that includes in both lists 2 people that are majoring in both. Does that make a little more sense with the rule of counting there? Yeah, and the toughest part again is making sure, are we looking at a union or are we looking at an intersection? The easiest way I remember is that if you just connect like the letter N to intersection and the letter U to union, this almost looks like a U, it's just missing that piece. This almost looks like an N, it's just missing that piece. So one way to think about it. Excuse me. And then the formula itself, yeah, that's another thing you have to memorize. Okay, James, he said, will you do C intersect B complement using A? One thing we have to make sure of is which ones we have to do first. There should be parentheses around two of these. And I didn't. Oh, you put. Never mind. I see it. You put parentheses around these two. It's all good. It's my bad. All right. So we go back and we look at our three circles, A, B, and C. Okay. A, B, C. So call it area 1, 2, 3, 4, 5, 6, 7, and then 8 would be the very middle. Sorry for not drawing a bigger intersection. So we work inside the parentheses first, so we want to do C intersect B complement. Now, the circle that C, or the area that C encompasses, has 4, 6, 7, and 8. Now B is this circle, but we want B complement. So which numbers here would we use for B complement? It's everything that's outside of B. Right? 2, 4, 7, and 1. Yeah, we want everything that's outside of the circle B, so that would be here, 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 and here. Okay? And so now we need to resolve the fact that we're taking the intersection of these. So what would the intersection of these numbers be? What do they have in common, basically? They have 4 and 7 in both lists. So 4 and 7, those two represent the intersection. Okay. So we took the circle C and intersected it with everything outside of B, which results in these two areas here. Okay, now we still want to union that with A. So A encompasses, let's see, we have 2, 5, 7, and 8. So if we take the union of those now, excuse me, what would that give us? Good, good. 2, 4, 5, 7, and 8. Right. And so we would go through and shade all 5 of those regions. So 2, 4, 5, 7, 8. Like so. So essentially it's A plus the part of C that is outside of B, right here. Okay. Were there other questions with the Venn diagrams or the set stuff? Mm-hmm. That's good. That's good. Yeah, Mrs. Knisley had texted me before class. I think she knew that y'all were struggling with this, and she asked me to make sure to spend some time going over this material in particular. Yeah, and I think numbering gives you a little bit better visual as far as which elements of the Venn diagram we actually are looking at. It definitely helps to add some context to this. Yeah. Okay. Were there any other questions? I don't know if we have time to dive into exponents, but if you had any particular questions on exponents, we could talk about them now. Or save it till next time. Okay. All right. I think we're just about out of time, so maybe we'll just leave it till next time. So if you do have specific questions on exponents that we would like to discuss, or if you want to still just look at more examples, we can do that next time. If you still have questions on Venn diagram type stuff, whether it's something we went over today, or it's something you went over in the other part of this class on Tuesday, Thursday last week, let me know. You're welcome to send me questions through Canvas or email. I don't know what's going on with my math lab thing. I'll work on figuring out something, hopefully by Wednesday. Yeah. Anyway, I hope you all have a good rest of the day, and we'll do this again come Wednesday. So y'all take care. Have a good one. It's on Wednesday right now, but it's it's debatable at this point. But if you can do it, fine. If not, that's okay too. I'm not going to count it late if we have technical issues. So I mean, that's a whole other thing. Yes, class is over. Um, if you can do it in my math lab, it makes it easier for me, to be honest. But if you want to send it by email, that's okay also. Mm-hmm. Yeah, we'll definitely look at that next time with the exponents for sure. And I appreciate the pun.